Well, good afternoon, ladies and gentlemen. My name is James Jones, and I'm your presenter for the next segment of this event. I appreciate the opportunity to share some thoughts with you. The topic that I was provided was to look into the future, into the year 2064, to give you an idea of what I think you might see then. Well, when you say what's going to happen in the future, I mean, really, where do you start? And the place that I think you have to start is if you don't know where you've been, you don't know where you're going. So I think it'd be very good for us simply to go back to 1963 and see the lay of the land as it was then. And if we could travel back to 1963, you would find that in the logistics profession, we had experts in provisioning, we had experts in packaging, we had experts in creating technical publications. We had people that were the gurus of test equipment, support equipment. We had training development experts, and we had people that knew how to use and design and create facilities. These were a reality, and they worked very well. And 1963 was probably the pinnacle of each of these diverse organizations creating really good processes of how they did business. But you have to remember, we're in the late 1960s. If you were watching TV, the number one TV program was Bonanza, and everybody had a TV at home. But if you missed an episode on Sunday night, you had to talk to your buddies because there was no recordings. If you liked music, of course, the Beatles were number one back in 64, but if you liked that music, you had to have a radio to listen to your local radio station, or you have to go down to some place that had a jukebox, or maybe you had a phonograph for yourself. I mean, that's the world that we lived in. For communications and business, grab the telephone. But to make a phone call from New York to Los Angeles cost you $17. And if in today's money, and if you wanted to make a phone call for 3 minutes from New York to London, it was $101 for 3 minutes. We didn't do phone calls. It was all by letter. Some people had telex. You sit and wait every day for the FedEx delivery to come along. That's the way we lived. And if you look at how we live today, it was a totally different world. Back in that time, they had this magical thing where you could actually put a piece of paper on a machine, dial a phone, and somehow that piece of paper would be replicated at the other end of the phone line. They called it a facsimile machine. That's the world we were in 1964. Historically, the United States involvement in Vietnam was slowly building up, so it wasn't a big deal in 63, 64. All of a sudden comes along this Department of Defense directive, 4100.35. This was the monumental event that, in fact, has triggered our discussions today. It was the realization that all of those different logistics groups were doing good work in a vacuum. But through a series of events that we don't have time to discuss, the US DOD said, really, they ought to work together. In fact, in 1964, this document came out and used the term integrated logistics support and simply said on the government side, we want to take all of those different, really good expert organizations and put them under a single umbrella to do four things. Number one, have the design of the product consider support requirements. Put together a set of support requirements that can be interpreted in the design that relate to availability. Buy all the sustainment that you need, all the parts, all the tools, all the books, all the training, and then deliver it in service. This was the declaration. Now, this was a directive. It's a thou shalt, not a how to. In fact, when it came out, every service was given 120 days, 4 months, to come up with their method of implementation. A lot of people don't realize that the person that signed this, his name was Cyrus Vance. And you may not be familiar with Mr. Vance. He was a Wall Street lawyer that had been drafted into working for the Department of Defense. He was Secretary of the Army. He was several roles. He was the leader of the group that wrote the charter for NASA. He eventually took over from Henry Kissinger as Secretary of State. He signed this piece of paper. He signed this directive. And that means it was really important. And because of that, it got attention. This is high level stuff. This was not a directive that was put out by, some unknown people. This had a lot of horsepower. The problem was it was a directive, and everybody was given their own latitude on how to do it, to the point that DOD was forced 4 years later in 1968 to put out this integrated logistics support planning guide for DOD organizations. And yeah, I plagiarized because it says so in the book. If you read this, it says differences in the interpretation and implementation of the broad objectives exist at all levels. And what they're saying is, we put this directive out, everybody did it differently. Mass confusion. And so DOD was forced to put out this guide on how it should be implemented. And the key features use this word systems engineering. Systems engineering for supportability. In fact, and again, you can see I've just done a cut and paste out of this guide. It says, we've got to do this together. And that's what this was put out for, as a guide. And it highlights systems engineering as the methodology to implement supportability considerations in the design of a product. This is pure systems engineering. And you're probably familiar with the systems engineering V model. It was based on it. It says, here's our concept of operation, and we're going to go through and design it and eventually operate and maintain it to meet the requirements. In fact, one of my textbooks, when I went through engineering school, I actually had this diagram in systems engineering. Right here it says resource limitations. Put together the system design and the system resources, and then come up with measures of cost and effectiveness. Of course, I'm not going to take you through the whole thing, but this was systems engineering for supportability, and this was back in 1967. So this isn't something new, but we know if we go back into programs back in that time zone, there was a barrier. There was the idea that somebody designs it and somebody else supports it. Never the two shall meet, which has always been a challenge. If we go further along in history, we get up to 1971, and now we got this mill standard on how the government should implement ILS on programs. In fact, they had this worksheet. You have to remember, back in 1971, there were no computers. Everything was done by hand, but this was an attempt to get people to realize that you can't do the individual logistics disciplines in a vacuum. They have to be worked together. Even though we would look at this now and say, my goodness, that's unbelievable. They would do stuff like that with a pencil, but you did. Finally, we get to 1980, and yeah, we're 16 years later. Believe it or not, a majority of US programs still had not jumped on the ILS bandwagon. DOD Directive 5000.39 made ILS mandatory. Before, it was discretionary. It was a suggestion. But this was actually the big year because it mandated that every program, little ones to big ones, had to do all the things that they were supposed to. They were stated back in 1964. And it came out the same words. This made it mandatory. But we're still looking at what the defense should do to implement this. And something you have to remember that all of these documents were written as directives for the buyer. There was nothing in here for contractors. It suggested that contractors might participate some, but this was a guidance to the government. In fact, you can go back to this guidebook that was created by the Defense Systems Management College in 1986. This was an implementation guide down at the nuts and bolts level, how to write a contract, how to administer all of these things to achieve an expectation. There was this underlying process that I would call an elastic process. Started back in 73, and as we've gone through this, it has changed. This is the process that was created for the government to implement ILS in a program. It's still there. We're up to Tech America 0017 Alpha today, product support analysis, and it covers all of the things that the government is supposed to do. But there's an issue. I've said through my talk so far, done by the government. But we do know that the government's the buyer and we've got contractors that are the sellers. The government is responsible to implement ILS on a program, but their primary roles are to develop a capability for some amount of reasonable expenditure of funds. On the other side, we got the contractor who is there to meet a contractual obligation and to make a profit. So, two very different viewpoints of what this is all about. And the only thing that ties them together is their contract for participation as appropriate. If you took the latest of the processes, 0017 Alpha, it divides product support, which we used to call integrated logistics support, into 5 different segments. And the biggest segment is supportability engineering as a part of systems engineering. Now, if I had time to take you through a training course on product support analysis, you would learn there are 106 activities stated in the most current version. And they're divided into these 5 focuses. A lot of this, you'll see of the 106 activities, 65 are supportability engineering through systems engineering. But sadly, the majority of people who think about logistics support analysis, product support analysis, only visualize those logistics kingdoms that we had back in 1963. Pick the parts, pick the tools, write the books, do the training programs. In fact, the majority of the product support analysis process doesn't deal with that. It deals with designing supportable equipments. And just for clarification, here are the three: activity Charlie 1.9, Delta 1.1, and Charlie 3.6, which are out of 0017 alpha, are the only activities in the product support analysis process that create the physical support solution that is going to be the final source for all of our deliverable products. And that's good. And something you may or may not realize is LSA and now PSA do not dictate what a tech manual should look like. They don't dictate what all the deliverable products should look like. All they do is create a consistent set of knowledge to feed all of them. And I know that you're all aware of the AIA ASD specifications, and these are still evolving. I know there's been lots of different discussions on the utility and the implementability and things about them. And, you know, from my viewpoint, this is just a natural extension. And eventually we're all going to probably be here, which is fine. But I do want to point out to you that there is a very visual link between product support analysis, ILS, and the ASD specifications, which are output products. And that common string is obviously identifying the maintenance significant items, maintenance task analysis, level repair analysis, that then create the final products. And this is good. So I've, through my tirade, have sort of brought you up to where we're at today, so you can understand my viewpoint of where I think we're going. And when we say, you know, what's happening in the future, there was a very famous interview that was done in the 90s with Bill Gates, when Bill Gates was the top dog of Microsoft and computers were becoming the big deal. The interviewer asked Bill Gates, where will the computer industry be in 5 years? And his honest answer was, I don't know where it will be in 6 months. Things are changing so rapidly. And I have to make the same claim. I don't know. Things are happening so rapidly. I mean, where do you start? I mean, we could go in all kinds of different directions. And you know that on a daily basis, you find lots of different things. So if we want to go to 2064, well, we're going to have to take a ride. We'll have to go up on the Starship Enterprise into transporter room number 3 and say, Scotty, beam us up, take us to 2064. What will we find? I have this expectation that in 2064, product support analysis, integrated logistics support, integrated product support, whatever you want to call it, will be a mainstream activity within systems engineering. No more tossing it over the wall, but a complete collaborative environment where supportability and sustainment are equal partners in performance in the systems engineering world. Yes, model-based product support. If you try to Google a definition of MBPS, it will tell you megabytes per second. When we get to 2064, they're going to look back and say, 40 years ago, that boy from West Texas, he made up this definition, because you can't find one. What we're going to look at, we will be in the digital world. That means that product support cannot be a stepchild. Product support has to be an integral part of every decision. Now, some of you may be familiar with ISO 10303, which deals with data and data exchange. But within ISO 10303, Application Protocol 233, is systems engineering and how that is used in the product design and also the product support solution. This, I think, will be the foundation of the next generation. You're familiar with the idea of prognostic predictive maintenance. This is truly, I think, one of the next steps of being able to know when something may potentially fail, even though we have, and this is not CBM plus. This isn't where we've got some little indication of impending doom. This is a totally different concept, but it may be the next step. There will be inside the what we'll call the ILS profession, people who are into predictive maintenance algorithm development. This is getting people to understand how it all works together. That's what the profession looks like. But what about the individual logistics disciplines? 3D spares printing. Think about the provisioning process where we go and identify, I think we need to buy some of these in advance. We need to stock them here and stock them here and stock them there. What if the provisioning process as we know it today simply disappears? Think about a maintenance environment where the maintainer is out there doing a maintenance action. They found a broken part, so they go over to the part printer. Jean-Luc Picard called it the replicator. And they produce a part. So there's no casualty reports, no CAS reps. There's no non-mission capable supply. There's no aircraft on ground because they needed a part, they printed it, they went out and fixed it. But that means my entire idea of warehousing, shipping, supply chain management is going to disappear. It's going to be a totally different issue. In fact, we've already seen it. We can actually print facilities as you need them. No more having to dream up this and dream up that. The printed word, training development, two different worlds may collapse. They may disappear. Every item is going to have a code. We're going to scan that code and we're going to go to SUSTube. SUSTube is going to have what we used to think of as the tech manuals. It's going to have the training course. It's going to have all the different resources. And as needed, if a person is going to perform maintenance, they'll go to SUSTube. They may get a little training refresher. They'll get all the technical information that they need so that this idea of books and training just don't exist anymore. How are we going to get that knowledge? Well, we already have wearable devices so that you can access any of this. What's the next step? Well, maybe we'll just give everybody their own personal computer that they wear. So they just, by osmosis, they get it. How about having a hologram side by side to show you what you do? There may be this issue of instant flow of materials. We'll still have manufacturing of spares, but it may be different. In fact, we may have a whole fleet of these things moving stuff around. The sky's the limit. I'm sure you're familiar with the Internet of Things because you got a smartphone, you got a smart refrigerator, you've got a smart air conditioner, you got a smart car, you've got all of these different things. We're going to take it the next step. The supply chain and the maintenance chain are going to become one. There's going to be one flow of information. And the division between supply and maintenance will disappear. There will only be one sustainment capability. Artificial intelligence is on everybody's mind. And there's been so much bad press about artificial intelligence, but in fact, from our viewpoint, this may be one of the greatest things that ever happens. In the sustainment process, we create mountains and train loads of data, and it is humanly impossible to dredge through it and find stuff. There was a survey done just a couple of years ago of people at their job. And this survey suggested that 80% of the time is consumed looking for something, looking for this, looking for that. And only when you found it can you take action. Artificial intelligence is going to provide the facility for near instant access so that we spend very little time looking and most of our time actually doing our job. You remember the crew of the Starship Enterprise? You look at all these different folks. Yes, you could be a Trekkie. That's fine. But even the things that they dreamed up, you took commander data as, oh, okay, we have an android just working along with everybody else. You're going to see it in real life. In 2064, you're going to see Commander Data and all his children doing a lot of the things. And we're going to have to adapt to that process. What we're looking at is we're on the cusp of a revolution. You individually have to accept what's going to happen. You can't just keep looking to what we did in the past, because what we did in the past may be totally useless, be overcome by events. So stop trying to improve the past. The past is useless, so stop. And you see, I've been talking about breaking down the walls of division. There are these things called logistics kingdoms. Have you ever been in a meeting where somebody wanted to make a decision about the technical publications, but there wasn't any technical authors in the room? And somebody actually made a decision about the books? That's heresy. You can't do that. That's our bag of tricks. No more. And we've got to break down all the external walls that we fight against. So what are you going to do? Number one, get on the train. Stop trying to find problems with it. We spend so much of our time arguing about the bad rather than looking for the good. Don't try to put a square peg in a round hole. Go look for something to make the square thing round and use it. This is really taking yourself into the next realm of possibilities. Some of you have said in my courses in the past, and some of you, this is the first time you've ever heard me. I've always had this feeling working on multiple projects, and I've been in this business over 40 years. The ILS group is always the champion of the user. The ILS group is the only group, of course, this is my reality, is the only group that champions the needs of the user We're the ones that say, hey, it looks good, but if it breaks, you can't fix it. What are you going to do then? And we have to have that mentality, and we have to continue that. Being an old guy, I do have one thing in the back of my mind. What if my computer runs out of gas? What are we going to do? What if there's no more GPS navigation? Nobody will be able to find their way home because nobody knows how to read a map. Everything that you see in our progress today is bound to computers and processing and the internet. What if it disappears? Where is our plan B? I have a plan B. You may not even know what this device is. In my lifetime, I have seen this thing go from state of the art leading edge technology to the point where nobody really knows what a slide rule is anymore. When Neil Armstrong put his foot on the moon, all of the computations for that entire vehicle, the entire mission was made using one of these devices. We can live without computers. It's just, I don't know if we'll ever get there. So, what have I told you? Yeah, a lot of the things I've described to you probably fairy tale stuff, but you asked me what I thought would happen in 2064. I think the bottom line is, you know, we come up with different names. You can call it whatever you want, but what we do will never change. If you look back at what was put in concrete back in 1964, and you look 100 years into the future from that date, we'll still be doing exactly the same thing. We may call it something different. Maybe we'll actually be systems engineering for sustainment. Why we do it won't change. Operational availability, cost of ownership, that's why we do it. So what changes? It's the how. How do we do things? How do we achieve these objectives using every possible methodology available to us? And I don't know. I've enjoyed being with you and providing a little bit of entertainment. My name, my company, how you can get a hold of me. Hopefully, I've given you some things to think about. And best of luck to you, my friends. Have a good day.